Here we want to factor this completely. There's no greatest common factor, so we look at the two terms. It's subtraction, so it could be the difference of squares or the difference of cubes. Since the powers are the 8th power, that's even. That means it's the difference of squares. So since a squared minus b squared equals the sum and difference of their square roots, we need to identify what a and b are. A would be the square root of our first term, which would be x to the 4th, dividing the exponent by 2. And b would be the square root of the last term, which would be y to the 4th. So we can break it down into x to the 4th plus y to the 4th times x to the 4th minus y to the 4th. Now our first term is the sum of squares. There's no way to factor that. They're not cubes, so there's no other way to factor two terms. But our second factor, we can see we have the difference of squares again. So we need to identify our new a and b, which is the square root of each of these terms, which is x squared and y squared. So our first factor remains the same, cannot be broken down any further. But our second factor can be broken down into the sum and difference of the square roots, which would be x squared plus y squared times x squared minus y squared. Looking at each of these factors again, x squared plus y squared is a sum. They're not perfect cubes, so it cannot be broken down further. With the difference, this is the difference of squares again. So I identify the a and b again. The square root of the first term this time is x. Square root of the last term this time is y. So our first factor remains the same. Our second factor remains the same. But our third factor can be broken down to the difference of squares again, which is the sum and difference of the square roots, and it's now finally factored completely.